Hi, let's talk bonding. You need to know 3 types: covalent bonding, ionic bonding, metallic bonding, and you need to know properties of ionic, covalent and metallic compounds. I'm going to do a little series of them because you need to know them for your marks, you need to know them for the actual exam. So I'm going to start off with ionic bonding. Ionic bonding, you need to know the definition, and people always get it wrong. It's the electrostatic attraction of oppositely charged ions. Learn that sentence. The electrostatic attraction of oppositely charged ions. Oppositely charged ions are positive and negative. Electrostatic attraction is the opposites attracting. Let's get cracking. Okay, so as I said, ionic bonding is the electrostatic attraction of oppositely charged ions. So metals, generally on the left of the periodic table, always form positive ions. And to help you, group 1 always form +1 ions, group 2 always form +2 ions, group 3 +3 ions. We sort of tend to, these are variable, which is why they're transition metals in the middle. Non-metals will produce, if they're in group 7, -1 charged ions, so negative ions if they're in group 6, like oxygen, -2, and if they are in group 5, they will produce -3. We sort of ignore the 4th one for the sake of this. Group 0 do not produce charged ions generally because they are the happiest of all of the atoms because they have a full outer shell. The reason why any bonding happens is to get a full outer shell. Now, in a full outer shell, we have 8 is the magic number. Okay, so that is why in ionic bonding, generally, group 1 and group 7 absolutely love each other, and group 2 and group 6, because if you work it out, they all add up to 8, which means that they can readily bond with one another. So what we're going to look at is how the bonding happens, how you draw it to get that maximum marks, and also then the properties of the ionic compounds relating to the bonding. It's really important. Let's do it. Bonding, if you're asked to draw it in the exam, it's normally worth around 3 marks. So you would get 1 mark for drawing the atoms having changed to become ions by losing or gaining electrons. You would get a mark for drawing the brackets around each ion, and you get a mark for the charge also. So I'm going to do a really common example. I'm going to do sodium chloride because it's probably the most common ionic compound we talk about in science. So sodium is in group 1 of the periodic table, which means that it has 1 electron in its outer shell. Okay, so that's will gain a +1 charge. So when I draw that, I'm going to draw that having given away that electron. So what will happen, it has an electron there and it will give it away to chlorine. Now chlorine, I'm going to do crosses instead of dots so it's really clear I know what I'm talking about. Chlorine is in group 7, so it has 7 in its outer shell. So essentially this is the process that's going to take place. To get my 3 marks, I'm going to draw sodium, giving away its electron, so it's going to become positive. Chlorine is gaining that electron, so I'm going to be really clear that it's gained that electron, and it will gain a negative charge. So that is how I would draw that. And because that is positive and negative, they're going to be attracted to one another. I don't need to draw anything else. If I was to zoom in on all of this that had happened, all of the sodium atoms bonding with chlorine atoms, it would look like this. And it would be 3D as well. So this would be minus, this would be plus, this would be minus, this would be plus, etc., etc. This is called a lattice. They form, ionic bonds form giant lattices. And that giant lattice has certain properties, and you need to learn the properties. Got salt, which has the formula NaCl, state symbol S, because it is a solid. If I was to zoom in, all the particles would be lined up in a uniform manner, all of the ions, positive and negative, positive and negative, positive and negative, to form this solid lattice. Now this solid lattice gives rise to a lot of properties. The main properties you need to know is that it has a high melting and boiling point. That means it takes loads of energy, lots of energy, to break down this lattice. That's really important. They have a high melting point because lots of energy is needed to break this electrostatic attraction. They're quite brittle crystals, which means that they snap quite easily, and that's because if you move these particles slightly, you're going to get a positive, a negative, negative, or positive, positive, and they're going to repel each other. That's why they snap. They take a lot of force to snap, but when they do, they snap really quickly. Another important property that we've got to decide is Do they conduct electricity, ionic compounds? Do they? Let's find out. At least circuit set up so I can see if ionic substances like sodium chloride conduct electricity. So let's find out. I'm going to whack a whole bunch of that in there. That is solid sodium chloride. I'm going to turn it on. Electricity, because if we've got our lattice again here, in order for this to conduct electricity, these ions need to be able to move to either an anode or a cathode to be able to conduct charge. So it can't conduct as a solid because the ions, be very careful here, sometimes people put atoms or they put electrons, it's the ions can't move. Okay, the ions are in a fixed position. Okay, so that's really important. However, if I break up this lattice and free these ions, free them, then they'll be able to move and they, in theory, will be able to conduct electricity. Now, to get them into a liquid state, I'm either going to need to melt them, so they're either going to need to be molten, which means I'm going to have to heat them up and try and overcome these bonds. So difficult, such high melting points. So instead, I'm going to dissolve it and I'm going to make it aqueous. So let's see if that works. So I have got the same setup again, but this time I've got water in here. Okay, it's on. The light is not on. Okay, so what I'm going to do, just turn it off so it doesn't get too hot. And I'm going to add in some salt and see if I can get it to conduct electricity by dissolving, getting the water to break up that lattice. I probably should have found a way of holding my camera so that it wasn't. Stir that in. So this is soluble. So now instead of being NaClS, it is now NaClAQ. And let's see if we can get that to carry a charge. It's faint, but it is there. That is lit up. Look at that. Okay, it's faint, but it is there. So in molten or a dissolved state, ionic compounds can conduct electricity because the ions can move. Ta-da! That's pretty much it for ionic compounds. You need to know the definition. Electrostatic attraction of oppositely charged ions, by the way. What they happen between metals, non-metals, cations, anions. You need to know how to draw them in the exam. You need to draw the dot crosses. You need to draw the brackets, the charges. You need to know the properties, high melting point because of the energy needed to break those electrostatic forces, whether they conduct or not. No in a solid, yes in a liquid or molten, that they're brittle, that they're mostly solid, they're mostly soluble. All that jazz. It's all ionic. See you later. Bye.